Hello, in this video we're going to look at some of the terminology that is used in statistical tests and overview how we would do the different types of tests depending on the hypothesis that you are testing. So there are three main types of alternate hypothesis. You could either have less than, greater than, or not equal to. So in this example, we have that H naught is claiming that mu equals k. And the alternate hypothesis is that mu is less than k. So this is the first type we'll look at. So for your sample, you're going to have x bar for a certain sample size n. And you'll be interested in saying that the probability of x bar being less than k. As before, to be able to use our z-table, we'll have to change that value k into a z value. So how are we going to do that? Over here, the same as before. Let's call it z sub x bar minus mu divided by its standard deviation. The standard deviation of the sampling distribution is sigma over radical n. This z x bar is called a test value. And then, of course, you look it up on your table and you get a probability. We call this probability the p-value in this case, in these problems. And this is the probability that z is less than a particular value z sub x bar. Less than. So this is less than, it's the left of, it's one tail of your normal distribution. So this is called a one-tail test, in this case a left tail test. So this is the probability of getting a test statistic that is less than k. The other two options are to have an alternate hypothesis that claims that mu is greater than k, or an alternate hypothesis where mu is just not equal to k. This upper example is very similar. You'll have your p, the probability of x being greater than k, same symbol here and here. And of course that carries over to z is greater than or equal to or just greater than z sub x bar to find your probability, your p-value. In the case where you are looking at just not equal, look at the diagram here. We're going to be looking at these two tails. Okay, so what we're going to do is just find the value of one tail and we will double it. We want to know what is the probability of being further from the mean than zc or negative zx bar, negative zx bar. So what we're going to do is we're just going to double our p-value, or the probability. The probability is going to be half of the p-value. In the example above, the p-value and the probability are the same. For the two-tail test, we want both of those values, so we're going to look it up and find one value on our table, and we will double it to find the whole p-value. So if your z x bar is positive, that means you'd find this value to the right of it. If your z x bar is negative, you would find this value to the left of it and double it. Since our table tells us this area to the left of a value, let's use that negative one always. So we're going to z is positive. We're going to use negative zx bar. Here's an easier way. Just make it negative. Whatever zx bar is, take the absolute value, make it negative. Use that and we will double it. So the probability that z is less than the absolute value, negative absolute value. We want to make sure it's negative. And that's going to be one of our tails. That's this tail circled over here on the left. And we're going to multiply that by 2 because we want to have both tails. It's symmetrical, so if we find one tail, we'll double it. This may look a little complicated, but just if it's negative, great, use that z x bar. If it's not, make it negative. Okay. So your p-value is going to be a probability of being in the shaded area. In the upper example, the shaded area is just this one tail. And the probability in the lower case, you're going to find the probability of both those tails. Since they're the same, you find the probability of one tail and double it to find your p-value. So once it's doubled, that's your p-value. So that p-value represents the probability of being in that tail. So if that probability is very, very, very small, probably you did get that randomly. It probably means that your initial hypothesis, your null hypothesis, was incorrect. So now let's look at some other terminology we have. There are two types of errors that we could make. So what are our two outcomes? Our two outcomes are to reject. Let's try that again. Our two outcomes are to reject the null hypothesis or if we don't do that, we fail to reject. So those are the two possible outcomes for a hypothesis test. So let's see. If you make an error, you could do one when you should have done the other. So the level of significance, alpha, is the probability of rejecting H naught, but you shouldn't have. It's true. So there's a type 1 error. So you did reject it, but you shouldn't have. The probability of making a type 2 error is called beta or beta. So type 2 error is the opposite. Type 2 error is you failed to reject and you shouldn't have. Okay, so let's look down at our table. Type 1 error. Type 1 error, it says that H naught is true, but we rejected it. Type 2 error, H naught is false, but we didn't reject it. We did accept it as true. So there are two types of errors. You reject when you shouldn't have, you accepted when you shouldn't have. Let's look at these alpha and beta. So alpha is the level of significance. The level of significance is going to be your boundary. Are your results, are your p-values significant or not? This is going to be our boundary of whether we're going to reject or not. So let's look over on the left side. If we look over here at 1 minus a, if your null hypothesis is true and you accept it as true, you don't reject it, you made the correct decision. The probability is 1 minus a. You can think of this as your confidence level. One minus a is the confidence level. So we're used to the confidence level from chapter 8. So you have 1 minus a confidence that H naught is true. You are within that boundary. So remember, we're looking at the two tails. So if you're confident that you are within the boundary here, you're confident that you're there. Okay, let's look at beta. Beta is the probability that you make a type 2 error. 1 minus beta is called the power of the test. So that's the probability that you appropriately reject the null hypothesis. That's the strength of your test. When you make the right decision to reject the null hypothesis. So there are two types of errors, type 1, type 2. There are these two different Greek letters, alpha, the level of significance, and beta. Beta doesn't have its own name. 1 minus beta is the probability of making a type 2 error. 1 minus beta has a special name, which is called the power of a test. 1 minus alpha has a special name. That's their confidence level. So there's a lot of terminology. Feel free to keep looking back at this chart to help you. You don't have to memorize this. We're going to be using it to refer to, but we're going to be doing several of these questions, so this will eventually sink in. Okay. So how do we use this level of significance? Is our p-value significant or not? You got a p-value of 0.05, you got a p-value of 0.9, you got a p-value of 0.3, 0.03. Is that significant or not? So we have to compare our p-value to our alpha. If our p-value is less than or equal to alpha, we reject our null hypothesis and we say that our results are statistically significant. What does that mean? That means the chance of getting that probability, that p-value, was so small by just getting it randomly, right? You took a sample of size n, you got x bar. The chance of getting of